Hi, I'm Paul Robinson from Sony, and I'm here to talk to you about rotten green unit tests. I want to start by saying this is inspired by a paper I saw at the ICSI conference a couple years ago called Rotten Green Tests, and it was such an intriguing title I had to go see the talk. Their particular tool is tuned for the Faro programming language, which is a descendant of Smalltalk, so not directly applicable to C++, but the ideas definitely were. Step back a second and look at testing in Clang and LLVM in general. So we have some internal self-testing, verifiers. We have some specialized tools that let us exercise different layers of the system with more simply. We have executable API tests that call directly into the libraries, and we can code these to do whatever we need. End-to-end tests, mainly test suite, but of course there's the new cross-project tests that started up recently. Downstream projects are doing a lot of testing. People are doing exploratory testing. Godbolt is amazing. And then of course our end users produce bug reports on their own of all the ones that we didn't manage to find. This talk is talking specifically about executable API tests. So what do unit tests in Clang and LLVM actually look like? They are organized under these directories, organized by library, so that makes them actually kind of easy to navigate, figure out what's doing which. They're all based on the googletest open source framework, which is quite popular. What LLVM has done is import just the framework source into the LLVM tree. In particular, we don't have googletest's own test suite or any of its build infrastructure. And then we've added a few local patches, support for environments that googletest itself does not have support for, and a few LLVM specialized data types that we would not be able to live without. Unit test in general is organized into functions which are divided up into parts. The test literature terminology calls the first part a fixture, which is basically the setup, and that uppercase test macro is something provided by googletest. So in this case, we're putting together a small set and initializing it. Then we have one or more stimuli to exercise the API and make it do something interesting. And then we have test assertions that verify that it behaved the way we expect. And again, these uppercase expect macros are provided by gtest. So what makes a rotten green test? Again, a test verifies some aspect of the behavior of the software. A green test is one that passes. Well, actually, a green test is one that doesn't fail. If you try to apply the law of excluded middle, that means if it doesn't fail, then it must have passed. But as Dijkstra reminds us, we can't rely on that. And so the tests that don't fail but don't actually pass are the ones that we care about here. Rotten green tests look like they are validating test results, but these assertions are not actually executed. There's something about them that was written incorrectly. And these incorrect assertions don't fail. And so the test looks like it's passing when it in fact isn't. Here's an example. In the middle of this test, we have some collection instantiation groups, and we're iterating over it and checking that each member has a size of 1. Looks totally reasonable. Except that the way the test is written, instantiation groups is invariably empty, which turns this into a 0-trip loop, and that assertion is not executed. It might look useful, but it's rotten. So if you're trying to read the test to understand how the API works, well, you're kind of hosed because it's not telling you the truth. And this is one that I have fixed. How do we go about detecting these rotten test assertions? We need to statically identify all of the assertions, which with gtest is fairly easy. We can instrument the expect and assert macros that gtest provides. We record the source location and allocate a flag that says whether it's been executed or not. And then for better reporting, we want to associate the assertions with the test methods that they're contained in. run the test, set the executed flag whenever the assertion is executed. We need to do some data cleaning here. There can be duplicates, especially if the assertions appear in templates. Each instantiation will have the same source location, but it will be its own instance of the assertion. And so if you have a template with two different paths, maybe they're exercised by different instantiations. We don't want to call these rotten because, in fact, both sides are executed even though they're in different instantiations. False positives can also occur because of G-test features that let you control and subset the set of tests that are actually being run. And then finally, we report all the unexecuted assertions. And these, if we get everything else right, are the ones that are rotten. I prototyped this in LLVM mainly because I didn't know at the time that there was an upstream googletest project. It builds and runs with on Linux with Clang or GCC and on Windows. Haven't tried a Mac. Each of these combinations has its own idiosyncratic way of getting static allocation work, which is what we use for the executed flag. And so if I had a longer talk, I would go into the gory details, but we're not going to do that right now. This prototype has found real test issues, like that one we found, some zero-trip loops, some unreachable cases. We had one test that the author just refactored the whole thing, and another test turned out to be missing some initialization. So cleaned all that stuff up. The prototype still has too many false positives. It doesn't really integrate smoothly with Google Mock, which we would want it to do, and doesn't like the skip features and other ways to subset test execution. So it's giving it too many false positives. Just for grins, here's the dozen or so bugs in tests that I have fixed or reported to show that actually this stuff is kind of useful. Plans going forward, I'm planning to contribute this rotten green test feature to upstream googletest. That way it will get better design and code review from the project experts. And using googletest's own test suite means that I will figure out how to integrate everything with the other features, otherwise the test won't pass. It took a little prodding, but I did get internal Sony approval to make this contribution. So I'll be starting on that very soon. After it's in place upstream, then we can import it back into LLVM and then go back to fixing the Clang and LLVM unit tests that have these rotten assertions in them. We can then also think about applying this procedure to other kinds of tests. Lit tests, especially file check, are easy to get wrong, or you have typos in your check lines or whatever. So if we can come up with a way to make this kind of approach work for lit tests, that will be awesome. And thank you very much for listening.